This is a 45-minute long live stream from Agent 3 launch, extracting audio from file. Remember, we can look at our console to see what's going on here. So this is happening in the browser. So it's actually not going to another server. What we're doing is we're taking this 450 meg file. It's ripping the audio at our bitrate, 256 kilobytes per second. You can see here. So it's at a 108x speed. So, if it takes 45 minutes, this is 45 minutes long, about 100 times faster, 0.45 minutes, or about 30 seconds. And you can see here, we're ripping through it. Okay, cool. Audio extracted. So we got our audio extraction. It's uploading the audio. We can take a look at app storage in our private folder. We'll refresh this just now. So because we went with the higher audio quality, it's a bit larger. Hopefully Assembly can track that. We're posting on the audio upload URL with our 2 key terms for improved accuracy. And then we should get back our transcription from Assembly. This could take a minute or two because it's a 45-minute long video. I don't know how fast Assembly is though, so let's see. Hello, we're live. Great to see you. Welcome to the Agent 3 live stream. We're super excited. We got a lot to talk about. I'm doing well, where it's launch day. This is the live streams. Yo, today we're building a video transcriber. I'm excited about this one. It's gonna be one of the more complex builds. I'm gonna walk through architecture design, my thought process, exactly how I build apps with AI. We're gonna use Replit. Let's just get into it. So we're building a video transcriber. I left this blank for a reason. We're gonna talk about the architecture. We're gonna talk about what it does. We're gonna break the problem down. So what would a good video transcriber do? So I make a lot of video. Transcription's a big pain. Often you have to use Premiere Pro or a third-party service. We're gonna see if we can do it ourselves. So first, we're gonna drag and drop a video into a web app. That video is going to have the audio extracted and uploaded to a AI transcription service. Now, there are a bunch of services that do this. OpenAI does this. For this video, we're going to use AssemblyAI because I've just heard of it and it sounds cool and I want to show people how to build with it. So we're probably going to use AssemblyAI, but there are a bunch of services that do this. We're going to get the transcript and then we're going to do stuff with it. So a lot of times these transcripts will have proper nouns wrong. Like Replit is a great example. Often that'll become like a replete or relit, which I don't even know is a word. Same thing is true of like Matt Palmer. I won't go into what it gets corrected to because I don't want any nicknames coming from my YouTube subscribers. So we'll skip that one. But we'll need to do some correction. So sometimes with these services, you can specify keywords. So actually, when we upload the audio, what we might do is specify keywords. Words, if API allows. I don't know if the API allows it, so we'll have to take a look. OpenAI does allow it, but we're going to use Assembly, so we'll check that out. So we'll get the transcript. There still might be errors, though. So my goal is going to be to allow us to manually edit the transcript. Manually edit SRT, which is just a timestamp transcript, and download, or stretch goal is correct with AI. So we could pass it through to another, smaller model and get those corrections again. So that's the idea here. This is what I'm thinking for our app. Now let's talk architecture because this is really important for what we're building. So we're going to build a full stack app with a client, and we're going to have a server. Why? Well, when we have things like API calls going on, we need a secure environment to make those calls because we have API keys and we want to be the ones making those calls. The client is inherently insecure. So we're going to have a client and a server, and they're going to kind of communicate back and forth with each other. So we have our client, we have our server. We're going to have some communication going on here. That's great. And what I'm thinking is, right, if there's a drag and drop interface, our client is like what the browser interacts with. We're going to drag our file to the client, and then something's going to happen. And what we want to get back on the client is our transcript. Now let's think about how basically how this is going to happen, right? So we're going to drag our file onto the client. If we decide to do processing on the server, which means we upload the entire file to the server, then the server strips the audio, does all the stuff, and then returns it back to the client, right? That could be kind of rough. Why? Because if I have like a 6 gig 4K video, I'm gonna have to upload a 6K file, a 6 gig file rather, because the server is remote, whereas the client is in our browser. It's like JavaScript and stuff running in the browser. So it would be really cool. Well, it would be a really stretch goal for this video if we could decode slash rip the audio in the browser. So actually, that's going to be our stretch goal today. So what we're going to do today is we're going to try to build a client-side service that removes the audio. And what that means is that we're going to use something called FFmpeg, which is like, if you're familiar, FFmpeg is basically the GOAT. FFmpeg is the GOAT of video and audio. If you've ever done anything with video programmatically, you've probably used FFmpeg. Sorry, I spelled it wrong. FFmpeg under the hood. So it's like the GOAT. So we're gonna do some FFmpeg stuff in the client, and then what we're gonna try and do is we're gonna hand that off to the server. And this instead should be on the order of magnitude of like 20 megs instead of like 6 gigs. So then in the server, we can do fun stuff. That's where we're gonna like call AssemblyAI, since that's our transcription service. So we'll call AssemblyAI from the server. And there's actually an intermediate step here. We need to upload the file somewhere. So, what's going to happen is that, if you sent me an MP3 file back in the day before we all had Spotify, if you sent me an MP3 file, I would have to go to that URL and it would have to exist in the browser. It would have to exist on the internet to listen to it. The same thing is true here of our audio file, right? So like we need some sort of storage. This is typically called object storage, like Google Cloud Storage or S3. In Replit, we call it app storage. So app storage is going to be where our file gets uploaded. So our server is going to upload the file to app storage, and then assembly is going to access that file. So assembly is saying, oh, hey, there's the URL. I'm going to get this URL. I'm going to transcribe it, and then I'm going to return that to the server. And that's where we're then going to pass that back to the client, and we have a transcript. And then we might want to do other stuff, like I mentioned earlier. So we might want to take the transcript and decode it. We might want to allow edits. We might want to fix the transcript. I think repair is a better term here. Repair. So now we have kind of what's going on. So we need a client, a server. We're going to need this thing, app storage, and we're going to communicate with our assembly service. I kind of skimmed over the FFmpeg thing. We're going to rely on AI for this, but there's actually a framework called WebAssembly that allows us to run FFmpeg on the client. This is complicated. We're going to rely heavily on AI to just take care of this for us, and we're going to debug it as it goes along. So now let's take a look at the assembly docs. We're going to look at the assembly docs, take a look at FFmpeg, and see what we're going to build with. So like I said, assembly allows you to transcribe audio. So you can actually see here, transcribe an audio file. And this is a great sign, right? Like this page here in JavaScript appears to have everything that we would need. So this is actually great. This is a great reference. I'm going to copy this URL. Now, if we look at FFmpeg WASM, as I mentioned, FFmpeg WASM enables video and audio record, convert, and stream right inside browsers. This is cool. Now you might be saying, Matt, like, how did you know about this? I knew about this just by like being inquisitive and poking around and doing research. You could use AI to do research, but that's part of building. Like as you build, you learn about different frameworks, you learn about different things to try. And so kind of in the back of my head, I'm like, oh, I know of this thing, FFmpeg WASM. I've never built with it, but we're going to try it out today. We're going to see if we can get it to work. And like in the docs, usage. Okay, this could be this shows you how to fetch the library and load it in the browser. So I think this page will also be useful for for our agent. So, you can see examples of basically loading this library straight from the browser. So we're going to use FFmpeg WASM. We're going to use AssemblyAI. And the other thing that I wanted to check on AssemblyAI, let's go back there. AssemblyAI is if we upload transcribe audio. Interestingly, we can also upload a file directly to Assembly, so we wouldn't need, or not really. We'd already need to upload that. So in this, in this API, what I'm looking for is, can we upload some sort of like keyword, right? Can we upload or describe? There we go. Key terms. Improve accuracy with up to 200 or 1,000 domain-specific words or phrases, minimum 6 words per phrase. So, or maximum rather. So, like what I'm saying here is, hey, if we said Replit, if we said Matt Palmer, we would be able to basically improve the accuracy of the transcript through those key terms. So, kind of have our tools assembled. We have some background information. Let's go to our prompt here. I'd like to build an app that allows me to upload a video and transcribe it using AssemblyAI. I would like the video upload modal on the right and the transcription displayed on the left, just a preference. We'll need to strip the audio from the video and compress it for more efficient upload handling. Ideally, we could do this on a client, so we never need to upload the entire video to the server. The uploaded video should be stored publicly in app storage, so it can be sent to Assembly for transcription. Do research to understand how we can strip the audio and build this app. You should return the text from the video, as well as an SRT file with timestamps from the AssemblyAI API. So I'm supplying those 2 pages that we took a look at. And I'm also saying you should strip the audio and store it with app storage, just to be very explicit. Build the simplest implementation possible. I'll provide my API key via secrets. I think this encapsulates everything that I'd be looking for in this app. So we're going to start building. And I'm just going to let agent run. Agent 3 runs for a bit longer now. So this might take, 15, 20 minutes. I don't think it'll take that long. I'll come back and we'll talk about what we got in the first build. Now, one other thing we'll need to do is log in to AssemblyAI and grab an API key. So once you log in, we should be able to go to our API keys here. And I have one already. You should be able to create a new API key, and then you'll get your API key. Agent will prompt you for the API key. You can just drop it in. So straightforward there, but necessary step. Okay, now we have our our video transcriber here. We're going to start testing it out. So again, this was just off the first prompt. I'm going to upload a 1-minute sample, pretty small, and we get a little. The design is pretty good. We got a little dark and light mode. Probably room for improvement here. And nothing's happening. So something's broken already. So the file does not exist at home runner workspace, no modules, v deps worker file. Okay. Try adding it to optimize deps exclude. So I've seen something like this before. Kind of need to know if you're using FFmpeg WASM, like we could bump into some things. The way that Vite works, which is a framework for running these types of apps, is that it optimizes our dependencies. The problem is that apparently that's not compatible with all dependencies. So what we'll have to do is exclude dependencies from optimization, and we're going to exclude our FFmpeg packages. So we go to our package JSON, we can see FFmpeg and FFmpeg util. So we're going to exclude those two. So FFmpeg, and add FFmpeg util. So we'll drop both of those, add a little comma here. We're going to restart our app because this is a backend change. So we're helping agent out a little bit here, a little gentle nudge in the right direction. This should fix the FFmpeg issues. Now we're going to try and upload that file again. Start processing. Okay. Whoa. So good news is that we didn't get an error there and our audio extracted. Bad news is that now we get a kind of ugly error here. Okay, so this is cool. You can see the FFmpeg logs coming in. So this is just like doing media stuff, which is sick. And then we get a failed to execute fetch on window audio API URL. So I'm just going to paste that guy into agent. We're going to We're gonna hope that agent can help us out with this one. I'm pretty sure that this has to do with the backend. A lot of times though, like just with these basic API errors, agent's good enough that if I just tell it there's an error, it's gonna see the error. Like it can read the console logs, it can read the backend logs. So I don't really need to worry too much about the specifics here. And sometimes I'll just rely on agent to debug these first pass, because AI is getting to the point where if I point it in the right direction and it sees what the error is, it's going to be able to fix it. And so it says the API request function expects method as the first argument and URL as the second, but I'm calling it incorrectly. So it seems relatively straightforward, the problem we're fixing here. All right, so agent claims there's a fix here. We're going to start processing that. We're going to see what happens. Okay. So good signs that we're getting different errors. Bad signs that the errors appear to be different. So we're going to turn off app testing for now. So new feature in Agent 3, it'll actually test the app in real time. So we can do those things, but that's kind of tricky when we're uploading video. So I guess we could upload our video file, but we're not going to do that right now. So what we see is that we're getting an invalid type error on upload here. So invalid type string, expected string, received undefined, path audio URL. So if we actually look at this, we have upload URL. So it's possible agent is passing the wrong param, error on upload. And I'm just going to send that along to agent. Usually with some of these more straightforward errors or things that like I can tell what's going on when I read the console, my thinking is that AI is good enough to just figure this one out. And again, much like the prompt I gave previously, yeah, agent is going to understand exactly what's going on here. Now, the exciting part is that it looks like something got uploaded. So if I go over to the app storage tab here, we can actually see our audio is coming through in our object storage bucket. Now it's going into the private folder, which I suspect will be an issue because we talked about in our architecture, these need to be publicly accessible files. So what I'm going to queue up to agent here are the files publicly accessible? I don't think assembly will be able to access them. And we get a little explanation of actually what was going on before, which is that the error was happening because the backend expected an optional audio URL field, but the validation schema was treating it as required. So very much just a type error, not actually something that's breaking functionality. And what you'll notice if you've built with Replit, if you built with any other tool, is that a lot of AI prefers TypeScript because these types can help us catch errors before they occur. So agent claims it fixed it. I'm a little skeptical because I don't think that the audio is publicly accessible, but maybe it's signing it somehow. So processing with AssemblyAI on the console, post API audio upload URL, transcription start, job ID. So it looks like it got the transcript and it started transcribing. There you go. Hi, my name is Matt, and today I'm here to tell you all about REPL.it in just 60 seconds. So actually, just like that, I guess I was wrong. Let's understand the architecture a little bit because right, the files are going into our private bucket and not our public bucket. How are our files being processed? I noticed they're private. How does assembly access them? And when we're asking questions, we can use the new plan mode that just explicitly instructs agent not to edit files. So for plan, I just kind of want to learn about my application. And so we're going to learn about what's going on here, and it'll explain to us the architecture. But we can also look into the server, and we can see like our object storage and our routes here. Let me explain how this works, and you can also check the Replit documentation. Love that. Get audio upload URL. So what I think is doing is we have our server. Let's take a look at this, and it's communicating through app storage. So rather than assembly talking to our app storage, it's actually talking to the server, and then the server communicates with app storage. So this is actually more secure, right? Because what that means is that this, like, we own this. This is very secure, right? Like, all of the information here is not accessible to the internet, and then we're explicitly allowing assembly to kind of talk to the server, but we can put protections on that communication so that only because it's defined in the server, only our information is going to WebAssembly. So this is actually a more secure architecture if it's working the way I think it is. So let's see. All private storage by default, secure access via signed URLs, temporary signed URL. Okay, so actually we're creating a 1 hour signed URL that allows get access to a specific file. So let's take a look at our architecture. What's happening here is, can I like move this around? I don't know. Yeah, there you go. Assembly's accessing this. However, it's via a temporary access and it's only available for a certain amount of time. So more secure. We could change the sign period if we wanted to. But the cool thing is that our app's working and it's like a secure app. Like this is the way that you should do things. So what's next? Well, we have our transcription here. We have a SRT. Let's take a look at what's in there. Yep, this is what I would expect. So we get our timestamps, which is nice. Let's see if we can add our keywords in. So we were in our assembly docs. We noticed our key terms prompt. What I'm going to do is I'm going to add in these docs. We're going to get the text content, and I'm going to say now add key terms before upload. I should be able to specify one or many key terms that are passed through to our upload in order to correct the transcript. We're going to go into build mode here. We'll ship this. Now I'm going to think through some other improvements, right? What I want to be displayed here is actually just the SRT. I don't really care too much about the text transcript. So can you display the SRT in the transcription window instead? We also need to make the SRT editable, right? Because we want to be able to edit that text. And we're teeing up the next feature, which is going to be able to repair the SRT via either GPT-5, either Gemini Flash, whatever we're feeling. Someone, I love that. Now add key terms functionality to improve accuracy. So it's going to implement our key terms. I expect this to be a smaller update because it's really just adding a couple components and passing those through to the endpoint. We also need to make the SRT editable so that I can correct text that needs to be revised. We don't need to worry about the text transcript for now. Why don't we need to worry about the text transcript for now? We're going to queue that up. Because what I'm worried about is basically having two objects here. So like I'm worried that we're going to have the text and then we're going to return the SRT. And really like what SRT is like 100, 01. You kind of saw a preview there to 0002. Hi, I'm Matt. And then we have 2, etc. But the thing is that this actually contains all of the information for the text transcript, right? Because you could imagine like deleting this, deleting that, deleting this, deleting that, and then you just have the actual paragraph. And so what I'm concerned about is that we have the text, and then we have the SRT, and then we're going to try to edit one of these, and then agent's going to like try and reconcile edits. We don't have what's called a single source of truth, which is like we kind of just want one thing that we're going to derive information from. So what I want my SRT, and then if we need text, we can build the text off of the SRT because all of the information from the SRT, from the text rather, is contained within the SRT, and then we have sort of a single source of truth, etc. So what's going on? Claims the backend has been updated. I'm impatient. I feel like I've said this before. We're doing it live. Like I want to see the things happening. I want to test things out. I want you all to see that with me. Key terms. Look at this. Separate with commas or new lines. So I could do Matt, Replit. Oh, that's the problem. This is the problem. Replit, Matt. We're just going to start processing it, even though agent says we're going to get errors. Okay. Using key terms for transcription. Post transcription get up. Oh boy. This is classic. Classic impatient bat. But what we're seeing is that we're using our two key terms. We're posting that transcription. Hi, my name is Matt. Okay, so it's correcting certain uses of Replit. I'm pretty sure these weren't there before. Let's see what happens if we do like lowercase Replit, right? Okay, so what you're seeing, right, is it's working. See, this was uppercase and now it's lowercase, but it's missing these first two terms. So while agent's working on this, what I'm curious about is I think FFmpeg might apply some compression by default, because when I listened to that audio, it sounded a bit grainy. It didn't sound as high quality, as high fidelity as when I originally uploaded it. So what we can do is we can go into the client and we can take a look. I want to see what's going on. So let's see if we can find lib FFmpeg. This is where our audio processing is happening. So we can see that we're loading these libraries. FFmpeg usually has these this command structure. And it's using a 128 kilobit per second bit rate for compression. I don't even know what that means, but that I would assume is some measure of how much the audio is being compressed. So what I'm going to do is I'm going to say audio compression bit rates. Okay, so it ranges 96 to 320. 320 is near CD quality. I mean, you know, I'm not saying I'm making a mixtape. Okay, agent's disabled. But what we're going to try, rather than doing 128, what we could try is something like 256. So we just double that. And we could see if that would present any improvement. So I'm going to wait. We're actually we'll edit this, and then we'll delete that so that agent doesn't start building it. And then when agent's done and it restarts the application, we have our working keywords. What we're going to do is we're going to bump the bit rate once agent's done working here. And then we're going to move on with our next functionality, which is the SRT functionality. Okay, so this is super interesting. All I did was bump this to 256, so exactly what we talked about. And then with our key term, it actually corrected the second usage here. So this was relit. Now it says replit. We're still one away though. So interestingly, right, the audio quality was actually to blame for some of these errors. So we're improving our transcription quality by providing higher quality audio. So I sent through our other prompt here. Can you display the SRT in the transcription window instead? We don't need to worry about the text transcript for now. We also need to make the SRT editable. So it just flowed through here. And what we're going to do is we're going to actually make this a bit more user-friendly. Like this word granularity is actually a little too low. So let's take a look at SRT, maybe time stamps. Characters per okay, so basically what I was looking for here is we don't want a one character per caption, and it looks like what agent is giving us is a much lower character per caption, right? We're getting one character per caption. So like actually let's search this. Does this exist? It does not exist. But what we'll do is we'll look at that that call in the server to assembly. Transcripts create, transcript request, transcript request audio URL. What we want to do is find where we're defining that request. And I know we had key terms as a parameter, right? So if we go here, transcription start, segments null. I was hoping to find just a very clear very clear definition of this, but I think we're gonna have to update our command to agent to say, hey, we're getting one word per segment here, and we don't want one word per segment. That's actually way too granular. So we're getting one word per segment on our SRT. That's too granular. You might notice I'm using M dashes. I just really like to use M dashes. There's some people out there that might say, hey, Matt, M dashes, that's AI generated. I like M dashes. I don't know what to tell you. So we're going to look at our params here by specifying the characters per caption. Interestingly, I think there's an error in, here it is. Transcribe, subtitles, transcript ID, SRT 32. So that's giving us our characters per caption. It's actually useful. So they're calling the subtitles thing here. So are we doing that? Maybe if we do a code search for subtitles. Then we're getting them through some other method. To decrease the granularity of our SRT. So I'm asking agent a question, hey, help me out with this thing because I can't really find it in the code. Part of the problem with writing code with AI is that it's hard to get up to speed on how things are structured or if there are multiple ways of doing things. So I'm going to ask agent to help me out here. The great thing is that this appears to be editable, so that's kind of cool. We can upload our video. Let's see what we get. So I'm just going to upload this. We want to test out our editor functionality now. Part of the problem, a new feature with Agent 3 is that you can test things. It can self-test. I disabled that for this application because, hey, we're uploading videos. Agent's probably not going to be able to upload a video just yet. Maybe it will be able to one day. So if I said, hi, my name is Matt, then if I download that, we want to check that has, look at that. You might not be able to see that. Beautiful. So this is what we want. It can be hard to maintain state sometimes with that SRT. So currently we're using AssemblyAI's word level segments, which creates one subtitle per word. They provide a sentence and paragraph level segmentation that will give us much better subtitle granularity. I love that. I love it. AI is doing the research. It's figuring out stuff that I didn't want to figure out. So this is great. Now we can start planning out what we want to happen next. So we have our SRT. It's a single source of truth. If we wanted to strip and get the text from that, we could. What we also have is over here, an edit functionality. So what we want to do is we then want to basically add a service that's going to take this, pass it over here to an AI model, and with a prompt, repair that function, the transcript. So what we need is then a prompt, a suitable model. So one of the cool things here is that there's some really large context models that are really fast. So if we look up Gemini 2.5 Flash, let's take a look. One of the things, I love Gemini. They do a great job, but they could just tell me the specifics of the model instead of sending me to this marketing page. That would be really great. Okay. Oh my God, this is crazy. I just wanted to know the tokens. Tokens. Maximum input tokens. Exactly. 1 million. So you can put a lot of stuff into Gemini 2 Flash. That's 2.5 Flash. That's what we wanted to get at. Same thing with Gemini 2.5 Pro. Flashlight, also same thing. So 1 million tokens is a lot. It's like, I think one word is on average 4 tokens. So it's like 250,000 words. So we should be able to just dump whatever we want to in here. And Gemini 2.5 Flash is really fast. So while while Agent's working on our sentences here, we're going to come up with our next prompt, which is now I'd like to add repair functionality to the SRT. That means passing the SRT to a model, Gemini. We're going to paste in that model name, Gemini 2.5 Flash, with our key terms and asking the model to intelligently correct the transcript. Looks good to me. So what I'm doing here is I'm kind of like, kind of skating where I think the puck's headed. It's a common term in, investing in AI, whatever. I'm pretty sure Agent's going to figure this one out. I know the issue. I think Agent has identified the issue. I'm thinking about the next feature. I'm thinking about what we want to build. Partly because I'm impatient, partly because that's just how I like to build. So what I think is that, we're going to be able to implement something. This is going to get to the sentence level, and then I'm going to be able to send this to Gemini, and we're going to get what we want. So I'd like to add repair functionality to the SRT. That means passing the SRT to a model with our key terms and asking the model to intelligently correct the transcript. Let's be more specific. I would like a repair button in the app that triggers this process and updates the text in the preview as well as the SRT I can download. So I'm pretty sure. Okay, so there's some issues that Agent's fixing, which is fine. But in the meantime, since I'm impatient, we'll process this and we'll see what's going on. Also, notably, I haven't tried out that 45-minute long video, so that would be a good test. It would prove out like bandwidth isn't an issue. So, okay, we didn't fix it. That's okay. We can help along Agent here, I think. So it mentioned the sentences. Whoa, this looks. Fetch sentences, transcript ID. Okay, so let's understand what's going on here. Okay, this looks legit. Is there a paragraph? All right, so before it was logging words, sounds like it's implementing the update for paragraphs. It's possible that I just need to restart the server because we made server changes. Boop. Upload URL. Sentences. Outstanding. I love this. This is much closer to what we want. So things are moving in the right direction. All right, so I'm going to add this repair functionality to the SRT. That means passing the SRT to a model, Gemini 2.5 Flash. We're going to send that to Agent next. It's going to restart. And then I think I kind of might want paragraphs. We can worry about that maybe a little bit down the line. But we're making progress if we think about what's going on here. Originally we said we want a drag and drop video editor to extract the audio on the client, right? Which we're doing. We want to be able to specify the keywords. We want it to go to AssemblyAI, which it's doing. We're going to get the transcript. There still might be errors. There are errors. We're going to manually edit the SRT, and we're going to download the SRT or correct with AI. So this is like this guy is the final boss that we're working on, the ability to edit it with AI. So it's going to add it with Gemini Flash. In the meantime, what I can do here is I can go to my secrets. And, I don't think I mentioned this. I got an AssemblyAI API key by just going to AssemblyAI. And then on the first run, Agent prompted me for that API key. And we integrated that into our app. So I'm gonna go to my account secrets, and I might have a Gemini API key. I don't. So what I'm gonna do now is I'm gonna go to Gemini. We're gonna jump back, and I'll have my Gemini AI API key. So I snagged my Gemini AI API key, and agent's prompting me for it. We're gonna paste that in and click continue. Perfect. So now we have the service integrated into our application. I'm gonna jump back once agent is done with this repair functionality, and we're gonna take a look. Okay, so I believe our repair functionality has been completed. Let's take a look. So I'm going to add my Replit key term. We're going to process it. We're going to double check one key term for improved accuracy. Okay, so not what we want. I can edit this, or I can click repair. And what's going to happen then is, it looks like, so it called Gemini with 0 key terms. So I don't think our key term got passed to Gemini, which is not what we want. But let's make sure that what we get back, 1 is a valid SRT, and 2 actually updates the text properly, right? Like those are probably the harder part of this. So it looks like it posted the transcription repair. Okay, I mean, like we got, it actually fixed it, which is pretty funny. So I guess it saw, right? It saw that Replit existed in the other parts of the transcript, but it didn't actually have the key term. So basically what we want to say is the repair functionality works but isn't passing our key terms properly. We'll send that. That should be a pretty simple update because we're passing the key terms properly to assembly. So my assumption would be that agent can pass the key terms properly to Gemini. That's just something that I think agent will be able to fix in one shot. So this is exactly what I wanted. The UI needs some work, but next steps would be like saving the SRTs in like a nice list, right? Adding a login functionality, like securing this, locking it down so that only we can access it, or the people that we allow to access it can access it, and a few other things. But we still haven't tried out our giant 45-minute long video file, which I was saving for the end for like a moment of truth because it'll be exciting. So we have to do that. I'm gonna wait until agent finishes this key term thing so that we can test it uninterrupted, and then we'll do a final test with our really long video and see how it works. Again, the cool part is it's 400 megs. Theoretically, we're not uploading 400 megs because it's happening in the browser. And I think that's really cool and really fun, but I'm a huge nerd. So I'll join you back when we're done with this fix and we'll get to it. Already, we got our repair using our key term. Actually, we can go in. I think it's probably worth doing here and checking our Gemini route to see what prompt it's using, because we generated this prompt. You're an expert in subtitle editing. Love that. Key terms, context, we're passing the key terms into Gemini. Agent just restarted the app, but like I have about a 99% confidence here that if I do this, once that's done processing and then we do the repair, it'll fix it properly. So we're using the right model, Gemini 2.5 Flash. We're going to repair this. We're passing our key terms to Gemini, which is what we'd expect. The prompt, this is like maybe a little bit much, but I think it's, it's good because a lot of times if you like see TikTok captions or CapCut stuff, it has like just incorrect grammar and incorrect words. This should largely eliminate that, right? And if you wanted to leave it at the word level and repair it, I think we'd do something similar. So we just got a repair back. It's fixed. It's using the key terms, and now this is a perfect transcript, right? So I'm basically giving you alpha here, like how to build the next $1 million transcript app, I guess. I don't know. All right, let's now the final, the sort of coup de grace, the Replit Agent live stream. This is a 45-minute long live stream from Agent 3 launch, extracting audio from file. Remember, we can look at our console to see what's going on here. So this is happening in the browser. So it's actually not going to another server. What we're doing is we're taking this 450 meg file. It's ripping the audio at our bitrate 256 kilobytes per second. You can see here, so it's at a 108x speed. So if it takes 45 minutes, this is 45 minutes long, about 100 times faster, 0.45 minutes, or about 30 seconds. And you can see here, we're ripping through it. Okay, cool. Audio extracted. So we got our audio extraction. It's uploading the audio. We can take a look at app storage in our private folder. We'll refresh this just now. So because we went with the higher audio quality, it's a bit larger. Hopefully Assembly can track that. We're posting on the audio upload URL with our 2 key terms for improved accuracy. And then we should get back our transcription from Assembly. This could take a minute or two because it's a 45-minute long video. I don't know how fast Assembly is though, so let's see. Hello, we're live. Great to see you. Welcome to the Agent 3 live stream. We're super excited. We got a lot to talk about. I'm doing well, where it's launch day. This is the live stream. So we can look through here. We can see Replit. So it got Replit right. And again, this is a 45-minute long video. We can go all the way down here. I guess actually we had over an hour on the transcript. Then we could test out a repair. Okay, so we actually broke the context window on Gemini, so we'd have to look into another solution for repairing these files. What you'd probably want to do is start chunking this up. So say, take the first part of the transcript, send it, fix, second part, send it, fix, or send all 3 in parallel. So it'd be like some async processing there. We're going to save that for another video. For this video, we just built a transcription app that rips audio from a video in the browser, sends it to AssemblyAI, transcribes it, returns that transcription, and then allows us to repair or edit the SRT. This is a real tool that I'm going to use in my video editing workflows, that I'm going to use for creating my content, my YouTube descriptions, and all of these things. And yeah, this is, Replit Agent 3. These are the types of apps that you can build. Hopefully you followed along here. Maybe you learned a thing or two. But I'm Matt. Until next time, peace.